Assalamu alaikum everyone. My name is Arish Asif Khan and I warmly welcome you to today's lecture. Today we are going to dive into an exciting topic, which is the names of some groups in the periodic table. Like I told you in the previous lecture, the group 1 elements are known as alkali metals and the group 2 elements are known as the alkaline earth metals. The group 17 are known as halogens and the group 18 are known as noble gases or precious gases. So the group 1 and group 2 elements, which are alkali metals and alkaline earth metals, they are highly reactive metals. But noble gases are stable due to their full outer shells. The full outer shell means that in the p block they have a total of 6 electrons and in their s block they have a total of 2 electrons. So 6 plus 2 is 8. That means that they form a full octet. Now the Aufbau principle states that the order of orbiting filling must be like this. So there are basically 4 types of shells and inside of those shells there are subshells. For example, K, L, M, N, and inside of K you have S, inside of L you have SP, inside of M you have SPD, and inside of N you have SPDF. So in S block you have 2 electrons, in P block you have 6 electrons, in the D block you have 10 electrons, and in the F block you have 14 electrons. But there are many elements which do not follow this orbital capacity. For example, hydrogen, its electronic configuration is 1s1, which means that it needs one more electron to form a complete duplet. Now I need to identify blocks, groups and period. Basically blocks ends in S. For example, S, which means S block, P, P block, D, D block, F, F block. So the S block is basically where the group number is equal to the valence electrons. The S block is group 1 and group 2, but the P block is from group 13 to group 18, which means that the valence electrons will be added with 10, so you can find the group number. Now periods are the number of shells. Example is of sodium. Sodium symbol is Na and its atomic number Z is 11. So its configuration will be 1s2, 2s2, 2p6 and 3s1. This last electronic configuration means that it belongs in the S block and it belongs in the group number 1 and its period is 3. Now aluminum's atomic number is 13, which means its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p1. Now as you is 3p1 here, which means that this 1 will be added with 2. This means 3. That means that the number of valence shells of aluminum are 3. Now I want to find the group number. So 3 will be added with 10. That means 13. So aluminum belongs in period number 3, group number 13 and in the P block. Now we have another example of potassium. It has an atomic number of 19. As you can see, its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. Now as you can see, potassium belongs to the S block, which means it has a group number of 1. Its period number will be 4. Now as you can see, we have bromine, we have chlorine, we have fluorine and we have argon. If you want to find the electronic configuration of these elements, you can do so by having the atomic number. As you can see, 35, 35, 9, 18. So if I want to find the electronic configuration, you will follow the same steps as you did above, and you can check which block is it in, which period number it is in, and which group number it is in. So the S and P block summary. Basically in S block, the group number 1 and 2 belong to the S block, which means that the group number 1 is equal to the 1 valence electron, group number 2 is equal to 2 valence electron. However, in P block, there are groups from 13 to 18 and it must be subtracted from 10, so you can find the number of valence electrons in the p block. There is also a d block, which is the transition elements, and the f block, which is known as lanthanides and actinides. Periodic table, these are the lanthanides, and these are the actinides, which are located below the periodic table. Now these yellow types of elements, they are known as transition elements, transition metals as you want to call it.